Hi, I'm Nihal. I will be presenting our work on learning to compose soft prompts for compositional zero-shot learning. This work is a collaboration with Palin Yu and Stephen Buck. Our key idea is to improve foundation models by learning to compose concepts as prompts. In this talk, I will be showing how to improve CLIP. CLIP is a vision language model used for zero-shot object classification. To illustrate this, let's build a cat and a dog classifier. First, we define prompts, a photo of cat and a photo of dog. Then we have a picture that we want to predict. We pass the prompts to the text encoder and the image to the vision encoder to get the representations in the joint embedding space. Then we get the predictions by choosing the prompt representation with the highest cosine similarity. This simplicity allows us to quickly build classifiers for several downstream tasks. However, it isn't surprising that CLIP is not perfect and often shows poor zero-shot performance on fine-grained classes. Let's look at a few fine-grained classes where CLIP doesn't do well. Here's a picture of a small dog, but CLIP thinks this is a sunny cloud. We suspect CLIP relies more on the color information here. Here's a picture of blue jeans, but CLIP correlates this with a blonde skater. These limitations motivate us to improve CLIP as efficiently as possible. Consider the list of fine-grained classes. We can decompose these classes into their constituent attributes and objects. Say we have 25,000 classes, which we get by taking the Cartesian product of the attributes and objects. In traditional machine learning, we would have to collect labeled examples for 25,000 classes. Collecting labeled examples for a large number of classes takes time and effort, and we don't want to do that. Instead, we make CLIP work in a compositional zero-shot learning setting, meaning we collect a labeled dataset for a subset of the classes, say 1,000 classes, and then we generalize to the rest of the 24,000 classes without any additional supervision. This idea both saves time and the cost of annotating data. This is where our method, compositional soft prompting, comes into picture. We have the same prompts for fine-grained classes, old tiger and young cat. We also have the corresponding token embeddings for attributes and objects. And this is what's cool about our method. We only need to learn the attribute and object embeddings. First, we plug the attributes and objects into the prompt, which we call as soft prompts. Then we use the same pipeline as before and compute the similarity scores between the image and the prompts. Finally, we calculate the loss and backpropagate to only update the weights of the token embeddings. Our approach moves away from the current trends in soft prompting and modularizes the prompts. This allows us to recompose them during inference. For instance, we recompose the fine-tuned embeddings to produce the soft prompts for young tiger and old cat and predict the same way. We perform experiments on the compositional zero-shot learning benchmark, which includes fine-grained classes defined by attributes and objects. Our results show that compositional soft prompting, or CSP, significantly outperforms CLIP on the standard datasets. CSP has several advantages made possible by the flexible text encoder. In our training set, we have compositions such as young cat. We ask this simple question: can we use the trained model to predict small young cat without any additional training? Our results on a newly annotated dataset shows that CSP improves unseen accuracy compared to CLIP. To further test the flexibility of CSP, we evaluate on a mix of pre-trained and fine-tuned vocabulary. Suppose we have a collection of fine-tuned concepts for attributes and objects. In the wild, we get a picture of a black dog. We can write a prompt for it in CLIP. But when we look inside our collection, we only have a fine-tuned concept for the object dog, but not the attribute black. So, can we plug in the fine-tuned concept for dog and use the pre-trained embedding for black? We find that plugging in fine-tuned concept in a prompt with pre-trained vocabulary can improve compositional performance. For more details, check out our paper and thank you for your attention.